All right, so today we're going to talk about MIDI and how to use MIDI devices with SuperCollider. And specifically, we're going to deal with MIDI input. So we have some MIDI controller. I've got SuperCollider set up here, and I've also got this M Audio keyboard controller over here. And the general thing we're going to do today is take data generated by this controller, pull it into SuperCollider, and use it to do something useful and meaningful. It's possible to send MIDI from SuperCollider as well, and to be received by a MIDI synthesizer or a DAW or something like that. It's pretty fully featured MIDI stuff in SuperCollider, but we're just going to focus on getting MIDI in, because in fact I think that's sort of one of the more common things to do. If we were to look at MIDI in versus MIDI out, in a lot of creative projects it's much more common to be pulling MIDI data in and using it to basically do a real-time control of synthesis parameters. All right, so I've got some code set up here. So we're going to boot the server and just create this relatively simple synth def, which makes an array of 8 detuned triangle waves, spreads them in stereo, and then passes this stereo signal through a resonant low-pass filter. And the cutoff frequency is the fundamental frequency times some harmonic number. So it's a way of being able to specify the cutoff frequency as a harmonic number rather than a specific value. And I'm clipping it just to be extra safe. The whole thing has a percussive envelope applied to it and an overall amplitude control, and out it goes. And I've just cooked up this simple routine as a demonstration. And little Easter egg here, nearest in scale is a clever little device. It's just handy for scale quantization. Instead of just having to manually pick from a large specific collection, we can just say nearest in scale, give it some scale degrees, and it will round those, and then we convert them to cycles per second. So just a little very basic sequencer. Right. So let's get MIDI involved here. And the very first step is to basically wake up the object that lives in SuperCollider that communicates with the rest of your computer and how it pulls in MIDI data, and just sort of connect SuperCollider with the MIDI world. And we do this with MIDI client.init. This can be done, this only needs to be done once. It can be done at the very top of your code. And it's saying to SuperCollider, we're going to start using some MIDI devices, so get ready. And it gives us some text in the post window. Specifically, it tells us the devices which can send MIDI, from which MIDI can be received, so a MIDI source, and also a device to which MIDI can be sent. And I have this virtual inter-application communication driver, which is active. And it also sees this Oxygen 49 MIDI controller. This is a plug-and-play device. Some MIDI devices need a driver installed. Most these days do not. So just about any standard lightweight keyboard controller is going to be immediately seen by your computer, and now SuperCollider sees it as well. And this is just one of 2 steps that need to happen. We also need to tell SuperCollider which MIDI devices we want it to specifically connect to and engage in conversation with. And what I usually like to do is just say MIDI in.connectall, which is just say connect to every device. You know, any one of these might be sending MIDI, and we want you to be able to listen to that device. And this doesn't seem to do anything special, but it's a necessary step. And I'm 99% sure you can omit this step. I think by saying MIDI in.connectall, you're implicitly waking up the MIDI client object. So I think, you know, trust but verify that this is correct. I think you can just run this line, and you're good to go. So does anything happen yet? No, we're still not out of the woods, but this is the first step. What I like to do, the very first thing whenever I'm dealing with MIDI, is to go into something that I would call MIDI debug mode. You can basically tell SuperCollider, hey, would you print every single piece of MIDI data that comes in? Just show it to me in the post window. And that is MIDI func .trace, and then a Boolean, whether you want to show all the data or not show all the data. So once we run this, now let's just press a key and hold it down. We see some data come in. So this is confirmation that SuperCollider is correctly, successfully communicating with this MIDI device. So it says MIDI message received. It's a note on message, the source ID of the device which is sending it, the MIDI channel it's on, the note number, and the velocity. And I assume everyone here is at least somewhat familiar with MIDI and the fact that it's this 7-bit system. So basically most pieces of data, there are 128 options. There are 128 different notes, 128 velocity values, 128 different program changes. Every continuous controller or control change value has 128 different values. And then I just release the note, and we get a note off message, same channel, same note number, and its release velocity, how quickly I released it. The channels, most human-written manuals think of channels as 1 through 16, SuperCollider, and in fact all MIDI programs under the hood think of these as 0 through 15. So that's a common point of confusion. Right now this device is transmitting data on channel 0, which to us is channel 1. So just important to be aware of the distinction there. Let's turn one of these knobs, and a whole slew of messages come in. Every time this knob moves by a tiny bit, we get another control change message. This happens to be controller number 22, and of course its values are between 0 and 127. And this is also a good way to actually see what kinds of data things are sending. For example, if I hit these, if I set this into program change mode and then I start pushing these buttons, you can see it's getting these program change messages. And the pitch wheel over here, that's giving us pitch bend messages, and the values are actually 2 to the 14 possible values. So anyway, it's all just numbers. And it's also a good demonstration that MIDI is not sound, and it's completely sound agnostic. It's just numbers, it's just control data, and it's up to us or whoever is developing some software that we're using to program it to respond to these messages in meaningful, desirable, useful ways. And that's sort of what we're going to do today. So now that we're done confirming that everything works, we can exit debug mode by setting MIDI func trace to false. And so now we can play these keys, and it's all still coming in, but we're not posting anything in response to it. All right. So there are two objects which are the primary objects we use for actually receiving MIDI data and defining some action to be taken in response to that data. And one of them is this one, MIDI func, and the other one is MIDI def. So there's MIDI func and there's MIDI def. These basically you would use one or the other. There's really no reason to mix and match most of the time. MIDI func it essentially just takes a function, and that function is evaluated when a certain type of MIDI message comes in, and MIDI def does the same thing. The difference is that MIDI def, like Synth def and P def and P def n, these are sort of proxy or proxy adjacent classes, which means if you create a MIDI def, you also give it a specific symbol name. And then if you redefine that MIDI def and it has the same symbol name, it overwrites the previous one. This is not the case with MIDI func. If you create a MIDI func and then just evaluate that code multiple times, you're actually making multiple responder objects, and this can create some problems. So personally, I prefer MIDI def because it's convenient for doing things on the fly and just kind of interacting with code. And if you make a mistake, no problem. You just reevaluate it, the mistake is fixed, and you haven't accidentally created a duplicate object that receives MIDI. I think this is just a sort of really a good option all around. So I recommend MIDI def sort of for everything. And we don't say .new here. Usually we use one of the other methods which creates a MIDI def that responds to a specific type of MIDI message. So it's possible to do new, but really what I like to do are, here's MIDI def.cc, which will respond to control change messages, MIDI def.note on, .note off, etc. So let's make a MIDI def that responds to note on messages. So we're going to say MIDI def.note on, and we'll put this in its own little clump. So the first thing is a symbol name, a unique symbol name that identifies this MIDI def. I'm just going to call it on. And then a function. And this function will be evaluated when a note on message arrives. So we can say note on received. And then we can stop there, in fact. We run this, and now note on received, note on received, note on received. So proof of concept, but this is not a useful thing to do. Maybe we can print the actual data associated with it. And to do that, we declare some arguments. And this is very similar to declaring arguments inside of a do or a collect. We can name them whatever we like, but they do have specific meaning in this context. And then the number of arguments and what they mean varies slightly based on the type of message we're receiving. But in the case of note on and note off and also control change, there are 4 arguments. It's the actual value of the message, which in the case of notes is the velocity, the message number. So in the case of notes, this is the note number. In the case of control change messages, it's the controller number. The channel this message is associated with, and the ID of the source device. And in a lot of cases, you actually don't need these last 2. It's really just the controller number and value, or the message number and value that we actually care about. But for now, we'll keep these here, and let's just post all of these. And again, here's MIDI def at work. We could just reevaluate the same one, and we don't have to worry about extra stuff hanging around. We can just play these. We get the velocity as the first one, highest velocity, very low velocity. Yep, and we're not doing anything with the note off messages, just note on. And so we've successfully taken in the values of this message into the function. And so now the question is, let's actually make it play music. So we have pretty much everything we need. I'm going to move this down past the synth def, maybe past this routine as well. And so we'll just grab this code, this synth code from the routine, and drop it in here. And we could run this. It's not quite done, but it's not responding to the note number in any meaningful way. It's just saying, to hell with your note number. I'm going to pick my own frequency. So we can say here num.MIDI CPS. And this should be sufficient, I think. All right. Let's get velocity in on the action here. So we'll say val .linexp 0, 127 to something reasonable like 0.05 to 0.6. We could go all the way up to 1. That wouldn't be bad. But of course, if we play 2 notes at the same time with maximum velocity, they're both at an amplitude of 1, and most likely we're going to clip. So, we like to stay down here. We could also do something like this, lin, and go like -40 to -12 dB amp. This is also fine. And the harmonic number for the filter is still random, but we could also tie this to velocity if we wanted. Make it higher with higher velocities, lower with lower velocities. Let's do 0, 127 to 2 to 30. And we don't really have to be too scared about high numbers here because we're clipping the values in the synth def. So we know we're not going to blow up the filter. And that's always nice. Did I run this? Not sure. Let's try. Just make it. I can't quite hear it. I'm not positive it's working. Yeah, it is working. I think maybe it's just not a particularly noticeable effect because the triangle wave doesn't really have that much energy, so we can do like saw instead. This might be a little bit more noticeable. Let's do 1. Yeah, so now velocity not only makes it quieter and louder, but also changes the spectral characteristics as well. So there's a lot of mapping we can do here. And also a Lin curve is nice here. Instead of always having to think in terms of linear and exponential mapping, Lin curve lets us arbitrarily control the curve. And so something like, you know, it's not an exact, it's not really true exponential anymore, no matter what number we pick, but somewhere around 2, 3, 4 is close to exponential. But if we make this like 9, we're going to have to really get close to 127 to hit the sort of upper range here. So I think this will be, get the idea. And this is lots of hardware and software programs with MIDI will do this. They let you control the velocity curve, for example, which just lets you decide how things are mapped. And it's very useful to get precise with expression and exactly how you want the performance to feel when you play it. All right. And this will take us pretty far, I suppose, but what we can't do right now is sustain the notes. We can hold the note all we like, but the fact of the matter is the synth has a finite duration envelope, which cannot sustain. So let's take the next step and make a sort of sustaining MIDI performance situation here. And so the first thing we need to do is change the envelope. I'm going to make this a triangle wave again. And we're just going to take this here and say env.adsr and give it a gate. So now if we take this here, actually we can just say synth try okay, so now we've got a sustaining synth, and now we can do something meaningful with the note off messages. All right, so whenever I teach this, I like to teach it the wrong way first because it's kind of instructive. Maybe the first thing you might try, let's make this as simple as we can, is you'd make a note on and a note off MIDI def. So we'll say this, we'll just fix this at 20 because we're not really interested in that at the moment. And you know, we can even just get rid of these. We're not even going to think about channel and source ID for the time being. So we could do like x equals synth.new. Again, this is the wrong way. And then we'll make a note off MIDI def. Got to give it a different name, of course. Even though it's a different type, it's the same namespace, so they need different names. And we're going to say x.set gate 0. We don't even need to declare arguments in this case. So we play a note, and we release it, and that works just fine, right? What's the problem here, though?
Try and play 2 notes at once.
Right. What happens if you try to play 2 notes at once? We hold this one down, play another one, and now we, you know, release that one. Works fine. Release this one. It's stuck. Stuck forever. We have to hit command period or something here. So the problem here is that we make a synth, we call it X. We make another synth, we call it X. And then we release that synth, but the first one, you know, it's not X, or it was X, but something else stole its name. so we can't talk to it. So this works fine as long as you only use one key. But the way to do this, and I just realized today this is actually in one of the MIDI guide files. There's a guide file called MIDI, there's a guide file called Using MIDI, and there's a section here called Playing Notes on Your MIDI Keyboard. And the approach here is to make an array of size 128 and store each incoming synth at the indexed slot determined by its note number, because there are only 128 possible notes in the world of MIDI. So if note 60 comes in, it goes in index 60, and the synth lives there on the language side. And when note off happens for note 60, we know exactly where to look and say, you set your gate to 0. And this way, all the notes have their own individual cubbies that they live in. And this is a very simple way to do 128 note polyphony. So let's do that. So we'll say the right way, right, we say notes equals array dot fill 128 nil. We're just going to fill it with nils. Right? Nil is what we're going to use to say there is no, that synth is not sounding, that key is not pressed down, there's nothing there. And when we get a note on, we're going to say notes dot put. We could also say notes at num. I could do it like this. I think this works just fine. We say, set the, store the synth at this, but you can also do it with put at num synth. And close parentheses. And when we get a note off message, here we actually do need to know the note number. We say notes at num dot set gate 0. And this is important, not crucially important, but a good thing to do is to overwrite that data to show the language knows that the synth is gone. Sorry, the server knows. The server knows that the synth is gone, no longer exists, but the language has no idea. So this is our way of manually saying, just so you know, this one's gone. So back to nil you go. So this should work. So monophonic mode seems to work just fine. I'm going to crank this up a little bit. It's a little quiet for me. Again, MIDI def, very nice. Just overwrite it. So let's play a chord. Works just fine. All right. And there you go. Just like that. 128 note polyphony. And if we look at notes, they're all nils again. If we play something like this and look at notes, there's a couple of synths tucked away in there. There they are. Release those, and they're back to nil. So we got the language and server working together very nicely here. Okay. Let's, from here, we have a couple of different angles we can pursue. And I'd like to get some other MIDI messages in on the action here. We have all these controllers. Right? This first knob here is number 22. This one is 23. For some reason, this is 61, 24, 26, 27, 62, 95. So just a bunch of. I'm just going to focus on this one here, this knob. So that's number 22, and it's sending values 0 to 127. First question is, what do we want to do with it? Right? This is our playground, our rules here. So what I would suggest, there's an idea here, is to let's use it to control the cutoff frequency of this filter. And so basically, we want to be able to play some notes. And then wow, wow, wow with that knob. And this is going to be a global effect. So if we have n notes sustaining and those keys held down, and we move this knob, we want to apply it to all of those notes. So I think this is a really good case for using a control bus to carry that control data, and so have the MIDI device update that control bus, and then have this synth read using in.kr from that control bus. So let's take this one step at a time, and we'll try to make this happen. All right, so I'm going to copy all this and bring it down here. First thing I'm going to do is, just so we can really hear it, I'm going to go back to a sawtooth wave and make the quality just a little bit higher, maybe something like that. And so we're going to make, I have a lot of questions here. For example, do we want to modify this value or just overwrite it with a new value? And I would say, we'll do, let's forget about this argument. We'll say we're not going to do harm anymore. Instead, we'll make a variable called harm, harmonic. All right, so it's just going to be reading from some control bus. So we'll make this bus for ourselves. And we need another synth def, which is just going to be responsible for piping out this control data on this bus. Call this the harm. Can it be this simple? I think so. I think that's all we need. I'm kind of doing this a little bit on the fly here, so you might need to backtrack and make a few corrections. But we just have a synth def, which is going to, I suppose let's lag this a little bit, just so it doesn't change suddenly. That might sort of click and pop the filter a little bit. And so what we're going to have is another control change MIDI def, which is listening for CC messages on controller 22, and it's going to set the harm argument. And this, we're going to have a synth called harm. It's just going to be sending that data out. This one's going to be reading from it, and it'll just plug it in here. So I think this works. I need to call, yes, right. In harm equals, we'll set that later. All right, forgot my in harm argument. All right, and we'll go ahead and make one of these. And remember how buses work. It's got to be, this has got to be upstream of the synth that receives it. So we'll say it's out is going to be bus. What did I call this? Harm bus. And that's all we need, I think. And so let's say the default group add before. So here is our node tree. And when we make this, it should just show up right there, just before the default group, which is where all of our note on synths are going to go. So let's make another one of these in harm bus. What else do we need? Nothing really. And I think we should be able to get the value of this bus. Yeah, you can actually talk to control buses much more easily in the language than you can audio buses. You can just say what value, it's just sitting at 8. And if we set this to something else, it gets updated. And in fact, this is kind of cool. On the, not that, but these, the stethoscope, which is, I think, s.scope, you can actually look at control buses. And there it is. It's not exactly meaningful here, but if we set this to 0.5, there it goes, and it's lagged slightly, so it kind of slinks down there a little bit. And you can change the scale a little bit. But, eventually it just kind of, we're going to be dealing with harmonics like 20, 30, whatever. So just proof that, we're actively writing a control signal to a bus. All right, and so if we make this, and then change this, that seems to be working. Sounds good? Okay. So then we just need to make another MIDI def that receives control data from this knob here. And do we need anything else here? I think, yeah, we should probably make a global variable. We'll just default it to 8 for no apparent reason. So whenever we make a new note, we want it to be using that global variable, right? Because if we turn the knob and then make a synth, we want it to know that that value has been updated. So it's not just enough to play a synth and then set the harm value when it moves. We also need to give it the proper initial value to avoid discontinuities. And that seems fine. So then we just need a MIDI def.cc. See, this is probably not a good name. Call this harm. And well, first of all, let's update the value. And we need to do a little bit of value mapping here. So we don't just want to say, we could do the value. I guess 0 to 127 is okay, considering we're clipping these values. But I'd rather do lin, 0 to 127, 2 to 40, something like that. And so now what we need to do is go through our notes array, iterate over the notes array, and update the harm argument for any synths that happen to be existing. And I think let's try to do this nicely. First we'll say, there's no, I think you can set, if we say nil.set harm 9, it doesn't complain, but this is just extra steps we don't need to be doing. Let's. I mean, but I think it's harmless. We'll try it this way. Notes.do arg synth.set harm. Close the function. And I know there's another thing we're overlooking here, but I think this should work. We'll find out. No, it's not working. Okay. I think I forgot something here. 8. I think it's this. I think these are not, maybe that's right. All right, let's just command period here. So we'll make this, and we should probably just make this at the top here. And now I've done it. MIDI CPS, comma, right here. def.cc. Let's start by posting these. Okay, so data's coming in. And it's being mapped. I think I figured out what I forgot. I forgot to actually set the harm synth. That's right. Yeah, I've got it all backwards. I'm imagining that I have to set something in the source synth, but really, I just need to set this one upstream synth. And the bus will so I was sort of mixing up my approaches here. We don't need to iterate. I lied. Let's see if this works. Oh, please, come on. Oh, I think it is working. Yeah. It's doing something. I would expect there to be less high harmonics here if we're going down to number of 2. So we set the harm to be 2. So it sends out a value of 2, reads it in. It might be this. Yeah, there is no harm here. What am I doing? Okay. What I want to see is this value. For some reason, I think I think I'm kind of mixing up approaches here again. So it's, when harm is 1, we just it's just the frequency. So what? Still though. MIDI CPS. So this is middle C, I'm pretty sure. It is. So if harm is 1, right, or 2, then that should be 880. Now it's working. What did I do differently? Okay, that's the sound I was expecting. I'm going to have to watch this again on the slow-mo replay after I upload it, so I apologize for the fumbling around. I'm not exactly sure why it's working now. Yeah, so now we have... All right. So that is the general approach here. We pick a parameter that we want to modulate, or we define some interactive mechanism. We want to change the sound somehow using one of these controllers. Usually this involves a global variable, so we can actually keep track of that value in SuperCollider. And then it's just a matter of changing these MIDI def objects in order to incorporate those changes. I think we have 10 minutes or so left, so I would like to try to add like a vibrato effect if we can. And I think I'm going to use the mod wheel for this. And we'll grab the sort of performance code here and grab our synth defs here. And I think I'm going to use the same approach, which is to make a new bus, make a new synth def, And then we have to think about how we want to quantify the vibrato amount. And I'm going to think about it in terms of semitones. So a +1, -1 semitone sort of thing. So we might as well do the conversion here. We're not really thinking about the speed of the vibrato, but we'll just say like 6 or 6.5, somewhere around there for normal musical vibrato speed. Bipolar, vib, lag it just a little bit. Dot MIDI ratio. So what comes out here on this control bus is a sine wave, a control rate sine wave, which is it ranges from plus minus vib, but then it's converted from a semitone value to a ratio. So for example, if vib were 12, the range here would be 0.5 to 2, a full octave in semitones, but as a ratio. So as long as vib stays pretty small, this is going to be a narrow range sine wave, and we just want to read it in and scale our frequency by it. I think it's that simple. And then we're going to want to make one of these. It does not matter where it is in relation to the harmonic synth, as long as it's upstream of all the receiving synths. And I guess we can give this a default value, just so it's not nil. I think if we don't give it a value the first time we play a synth, if we do it before moving the mod wheel, then it's not going to work. The main problem here is that right now this MIDI def is not filtering the data by controller number at all. It's actually listening to every control number. So if I go back to this previous example here and run this, whoa! Right. What's happening now is they're both affecting vibrato and something like that. So it's and all controllers are affecting all of these. What did I'll make sure to polish this up and make sure it's fully functional before I send it out. But basically, the short story here is after the function in a MIDI def, so we have the name of the MIDI def, and then the function to be evaluated, and then we can follow this up with a controller number. And that means this MIDI def will only listen to messages that are on controller number 22. You can also do an array. For example, if you only want to listen to these controllers, as long as the controller number matches one of these, it'll be fine. So here we want to use the mod wheel, which is controller number 1, and just to verify that, we'll go here. Yeah, controller number 1. It's the convention for the mod wheel. All right. Yeah. Oh, the reason that happened last time is because the default value for the input bus is 0, and so which also happened to be. So I think basically what was happening is these two input unit generators were reading from the same data stream, and so that's why it went. But I think we'll fix this here. So this one's called vib. We can delete this and delete that. And we'll say go from 0, because we want to actually bypass the vibrato when the mod wheel's all the way down. And then we'll go up to 2 semitones, just to be a little bit exaggerated with it. And then we say vib synth, set vib to be vib. And we also need to do this. Wait a minute. This shouldn't be in. It should be in harm. That's what I called it. That might have been part of the problem, is because it wasn't setting the bus, and maybe I had accidentally allocated multiple buses. I don't know. All in harm and in vib. And we got 2 buses, harm bus, vib bus. Okay. All right. Here goes nothing. I got to make these first, actually. So we got our buses and our 3 synth defs, and then these. Okay, this is still working. Yeah, that is a little too much vibrato, I think. So we'll say lin curve, only up to 1, and we'll kind of curve it slightly. So it might feel a little bit more natural. That seems nice. Yeah. And it's doing the thing again, where it's so we're not filtering it out all the way, which is and I do see that there are multiple synths here. That might be part of the problem. I think it is. All right. Well, that was a little messy, and for that I apologize. I thought I'd be able to sort of wing my way through this, but I stumbled a little bit, and I will try to prepare a little bit more robustly next time. So I'll give this another look over and make sure everything is working properly, and, you know, if necessary, make some changes. The homework for this week is going to be a lot of the same stuff here. I think just a slightly different. I want you to work with samples basically instead of synthesis, but make a kind of make a polyphonic synthesizer on your own and map one of the controllers to something. In the past, I've made an assignment where you have to make a functional sustain pedal. So that's actually more complicated than it seems, and it's sort of a reach assignment. If you complete this and if you've got a sustain pedal handy, or any other discrete control change message, you can try to actually be able to make a sustain pedal that functions like a sustain pedal on an actual piano. It's kind of a fun assignment. Okay, so I think that's it. You can keep an eye out for that homework assignment, and we'll see you next week.